let's work a couple extra examples. So first, we want to place the following ordered pairs on the rectangular coordinate system. We're also going to identify their quadrant. All right, here we go. Let's start here. -2, 3. So I'm going to go left 2 and up 3. So left 2, 1, 2, and up 3, 1, 2, 3. So there is -2, 3. And what quadrant is it in? Remember, quadrants start here with 1, 2, 3, 4. So this is in quadrant 2. All right, let's look at the next one. The next one is 4, 0. So that tells me I'm going to go right 4, and I'm not going to go up or down. So 1, 2, 3, 4, not up or down. So here's the point 4, 0. Now this is kind of tricky. What quadrant is that in? Well, it's not in any quadrant. It's not in 1, 2, 3, or 4. It's sitting on one of our axes, sitting on the x-axis in this case. So this has no quadrant. None. No quadrant. It's quadrantless. Okay. If a point is sitting on one of the axes, the x-axis or the y-axis, it has no quadrant. Okay. Turns out this is a special type of point known as an x-axis, or sorry, an x-intercept, because it sits on the x-axis. We'll talk a little bit more about that in the next section. All right, one of my favorite points, because it's a fraction. All right, I know a lot of people don't like fractions, but don't let the fraction part bother you. You know what this means. This means I go to the right 3 halves and down 5/4. The tricky part is thinking about how to do that. Well, 3 halves, right, means I'm going to split things into halves, and then I'm going to count 3 of them. So I'm going to split things into halves and count 3 of those halves. There's 1 half, 2 half, 3 halves. Okay, so this would be my right 3 halves. Then I have to go down 5/4. The fourths tells me I need to split things into fourths. Sorry, this is going to be a little hard to see. So I'm splitting things into fourths. And then I'm going to count 5 of them. So 1, 2, 3, 4, 5. So here would be -5/4. So my point is going to be right here. I went right 3 halves and down 5/4. Now, which quadrant is that in? Well, 1, 2, 3, 4, that's in quadrant 4. The Roman numeral for 4 is IV. Well, last but not least, this guy. This tells me I go left 5 and down 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So here would be the point -5, -7. What quadrant is that in? 1, 2, 3. That's in quadrant 3. Okay. All right. Now I want to find the distance between and the midpoint of these 2 points, -5, 4, and -2, 2. Well, we're going to use our formulas, but I'm going to go ahead and just sketch a quick graph of these 2 points because it might help us determine whether or not our answers, when we're done, are reasonable. Okay, all right, so just plotting these 2 real quick. I've got -5, 4, so that's 1, 2, 3, 4, 5, 1, 2, 3, 4. So here's -5, 4, and I also have -2, 2, so -2, 2. Okay, and we want to find both the distance and the midpoint between those 2. Okay, let's start with the distance. So remember our distance formula. Okay, it says to find the distance between any 2 points, x1, y1, and x2, y2, we do the square root of y2 minus y1 squared plus x2 minus x1 squared. That comes from the Pythagorean theorem. So I'm going to make my first point x1, y1, and my second point x2, y2. I'm creative like that. So now plugging into our formula, I'll have y2, 2, minus y1, 4 squared, plus x2, -2, minus -5 squared. Now let's simplify. 2 minus 4 is -2, so I'm -2 squared, plus -2 minus -5 is -2 plus 5. -2 plus 5 is 3, so 3 squared. -2 squared is 4. 3 squared is 9. 4 plus 9 is 13. So I have the square root of 13. That certainly does not simplify. So our distance is going to be the square root of 13. Okay? All right, so now let's think about our midpoint. Our midpoint, remember, we can think of as the average of our x values and the average of our y values. So our midpoint, right, the midpoint between any 2 points, x1, y1, and x2, y2, looks like this. x2 plus x1 over 2, y2 plus y1 over 2. All right, so let's plug in here. Oh, it's hard to see, I'm sorry. So x2 is -2. So -2 plus x1 is -5 over 2. y2 is 2 plus y1 is 4 over 2. Okay, all right. -2 plus -5 is -7 over 2. 2 plus 4 is 6 over 2. -7 over 2, we can leave that. That doesn't reduce. If you are more comfortable, you can think of this as -3.5. 6 over 2 is 3. Now let's see if that makes sense in terms of our picture. This tells us that our midpoint should be at -3.5. 1, 2, 3.5, 3. 1, 2, 3. Does that look about right, given the fact that I don't draw perfect pictures? Yeah, that looks pretty close to right. Okay. My math lab should accept both -7/2 or -3.5. Just double check what they ask for. See if they say integer. If they say integers or fractions, you're going to have to use the fraction, and you're going to have to make sure that the fraction is reduced.